Hello Intro Chem friends. This next video is going to deal primarily with redox reactions, but before we do that I wanted to revisit this slide about total and net ionic equations. In this total ionic equation that I have here, let me get my pen again, in this total ionic equation we have everything that is split up into its cations and anions if it was aqueous. Things that are solids and liquids and gases stay together. So this was our total ionic equation, and to get the net ionic equation, we canceled out species, ions, that were identical or the same in the total ionic equation. So these ions that are the same on both sides of the total ionic equation have a special name. They are called spectator ions. Essentially, they are ions that don't participate in the reaction because they cancel out on both sides. They appear unchanged, and so they appear unchanged on both sides of the total ionic equation. And since we can cancel them out, they're not shown in the net ionic equation. So you should know the term spectator ions, know what it means, and be able to identify them in a total ionic equation. Now let's go on to redox reactions, another type of chemical equation of chemical reaction that we talk about. So in redox reactions are also called oxidation reduction reactions. And the main hallmark of oxidation reduction or redox reactions is that they involve the transfer of electrons. Electrons. So to remember about what happens in a redox reaction, I like to use the mnemonic Leo goes Gur. Another one you may have heard of maybe in a previous chemistry class is oil rig. Okay. Both of these work. Both of these mnemonics are just ways to remember what redox reaction means, specifically the definition of oxidation and reduction. So in a redox reaction, something is oxidized and something is reduced. Something that is oxidized loses electrons. Something that is reduced in that reaction gains electrons. So hopefully you can see why Leo goes Gur and oil rig would be two ways to remember what an oxidation reduction reaction is. Leo goes Gur means loss of electrons, oxidation, gain of electrons, reduction. Or you can remember oxidation is loss and reduction is gain of electrons. Whichever one floats your boat and helps you to remember the definitions of oxidation and reduction and what an oxidation reduction reaction is. So with oxidation and reduction, they go together. Since in oxidation something loses electrons, the electrons can't just be flying into space. Something else needs to capture them. The species that captures them is reduced. So just like peanut butter and jelly, they always have to go together. So if something is oxidized in a reaction, something must be reduced as well. You can't have one without the other. Okay. So I have an example of an oxidation reduction or a redox reaction here. So So one of the things that you will need to do in your exam and also in the Redox lab that has already been posted is you're going to study those reactions, but you also need to say something about or determine what species is being oxidized, which one is losing electrons, and what species is being reduced, which one is gaining electrons. So when presented with a balanced chemical equation, to determine if something is oxidized and what's reduced, you need to know something about the charge of that species. Because remember, if something's losing electrons and something's gaining electrons, electrons are negative, right? Electrons are negative. So by gaining or losing an electron, you're going to change the overall charge of that species. So if I know what the charge of something is before the reaction and after the reaction, I can compare that and then determine if it's been oxidized or reduced. So let's do that with this chemical equation along with a few other rules that I have listed here. And believe it or not, some of those rules you already know, which is that when in an ionic compound, monoatomic elements have the charge of the particular group trend that we talked about. So for example, sodium. Sodium, when in an ionic compound, hey, here's sodium right here. It's in an ionic compound, metal, non-metal. When in an ionic compound, those elements have the charge that we talked about previously. Sodium's in group 1. So sodium in sodium oxide here has a charge of +1. Okay. So that's the first rule. The second rule is that any element by itself, like for example, just carbon, or in this case, sodium, any element by itself has a charge oxidation state of a big fat 0. So on my reactant side, sodium, that is an element by itself. What is its charge? It has a charge of a big fat 0. Same goes for oxygen as well. Any element by itself has a charge of 0. So oxygen as a reactant has a charge of 0. When I come to my product side, now oxygen's not by itself, right? It's in an ionic compound. So it's going to have the charge that you memorized from Unit 2, the periodic table. Oxygen's going to have a charge of -2 when it's in that ionic compound. So these two rules are going to be helpful to you in this course when determining in a redox reaction if something is oxidized and something is reduced. So we've looked at we have our charges here. Let's determine in this equation, in this reaction, what's being oxidized and what's being reduced by comparing the charges. Sodium, as a reactant, it started with a charge of 0. As a product, it now has a charge of +1. Now, remembering that electrons are negative, and looking at sodium, did it gain or lose an electron? Well, it became more positive, so the only way to become more positive would be to lose an electron. So since sodium lost an electron, it's going to be oxidized because oxidation is loss. Oxygen, as a reactant, had a charge of 0. As a product with the sodium, it has a charge of -2. So it gained electrons. So therefore, it is reduced. So, since sodium lost electrons, it is oxidized, and oxygen is reduced in that reaction. Okay. Let's talk about some other examples, other ways to identify redox reactions. Combustion reactions, things that react with oxygen, elemental oxygen, that just means oxygen by itself. Species where you have a metal reacting with a non-metal, those are redox reactions. Also, single displacement reactions are redox reactions. And this is probably one of the more important ones for Introchem, because your redox lab in experiment 7 is all about single displacement reactions. Okay. So you should know these subcategories of redox reactions, and you should be able to use the rules that we talked about in the previous slide to determine what's being oxidized and what's being reduced. Not so much with combustion reactions, but you should be able to do that with these two examples, metal reacting with non-metal and single displacement reactions. So let's just kind of talk through that here. So in this balanced chemical equation, solid calcium reacting with chlorine gas to give calcium chloride. What's being oxidized and what's being reduced? To do that, we need to know something about the charges of each. Calcium by itself, it's not bound to anything else. We said any element by itself has a charge of 0. So it's both calcium and chlorine will have charges of 0s. As a product, calcium that's now in an ionic compound. Calcium's in group 2, so it's going to have a charge of +2. Chlorine, Cl, it's now in an ionic compound. It's in group 7, and those guys like to have a -1 charge. So when comparing the charges of each species, calcium went from a 0 to a +2. And remember, electrons are negative. So to become more positive, calcium had to lose electrons. And chlorine, to become more negative, had to gain electrons. So in that metal with a non-metal example, calcium is oxidized, chlorine is reduced. Let's do the next one. Zinc solid reacting with HCl to give zinc 2-chloride and hydrogen gas. This is also a single displacement reaction. Single displacement because you have one species changing places with another species that's in an ionic compound. Let's look at this reaction and determine what's being oxidized and what's being reduced. Zinc as a reactant, any element by itself, remember, has a charge of 0. HCl, well, that hydrogen, it's bound with the chlorine. It's in an ionic compound. It's an acid, but it's in an ionic compound. Hydrogen's in group 1, so it has a +1. Chlorine's in group 7, so it has a -1. Now let's look at my product side. Oh, I see chlorine. Chlorine is bound with the zinc in an ionic compound, so it's going to be a -1. Since there's 2 chlorines there, for the charge of that molecule to equal 0, my zinc better be a +2. Okay, since I have 2 of the chlorines. Next, my hydrogen gas. It's not bound to any other metal. Any element by itself has a charge of 0. So we've identified our charges. We can compare zinc. Zinc went from a 0 to a +2. So zinc has lost electrons, so it is oxidized. I'm just going to put lose because my writing is horrible. So it lost hydrogen. Hydrogen went from a +1 to a 0. So it became more negative. So it gained electrons. And since it gained electrons, that hydrogen is reduced. 2 more points to make. What happened to the Cl, to the chlorine in this reaction? Did it get oxidized or reduced? Well, Cl started as a -1 on my reactant side, stayed a -1 on my product side. So the Cl atom wasn't oxidized or reduced at all. Everything was all just about the zinc and the hydrogen. Next point is that about the Canvas bonus, as I mentioned on the updated syllabus, no bonus for no more bonuses. I will try to put that video up just for you to take a look at, but just want to let you know that. The main points of redox reactions that I want you to know is the definition of redox reaction, definition of oxidation and reduction, being able to identify a redox reaction, and being able to tell if something is oxidized or something is reduced based upon the charges of the species involved.